Guys, and welcome to Unit 4 of our lecture for MST 4, Living in the Era. For this week, we will be talking about computers as part of our journey. The essential questions that we have for this lecture are: how does the computer work? How does the computer interpret data? How do computers communicate with one another? For our intended learning outcomes, these are the following: articulate basic, fundamental definitions of complex issues and dynamics of humans, counter every day, such as technology, social progress, development, and digitalization. Define the types of networks, wired and wireless connections used in the computer system, as well as the desktop applications and mobile applications and their relevance to day-to-day activities. Evolution of computer networks. Studying the evolution of any area of science or technology will not only stimulate your natural curiosity, but also give you a deeper understanding of the main achievements in this area, make you aware of existing trends, as well as helping you evaluate the prospect of specific developments. Computer networks emerged relatively recently in the late 1960s. They have inherited many useful properties from their predecessors, namely older and more widely adopted telephone networks. As we can see, according to our lecture, computer networks evolved from telephone networks. So without telephone networks, there will be no computer networks. This is not surprising since both computers and telephones are universal instruments of communications. One more information to add. During the early stages of the internet, there were no lease lines or fixed lines to connect to the internet. It's not unlike right now, wherein you have mobile networks such as LTE, 4G, 5G signals, as well as cable, fiber optics, as well as satellites to deliver internet connection. In the early days of the internet, people usually use phone lines in what we call as dial-up modems in order for them to connect to the internet. So during those times, the maximum attainable speed was 56 kbps, and then the actual download speed was probably the maximum was around of that 56 kbps. It could range from about 5 to 10 kbps per second. So imagine how slow internet was during those time. But as you can see, the correlation is that without telephone networks, there will be no computer networks. However, computer networks have brought something new into the world of communications, namely the practically inexhaustible store of information accumulated by human civilization during the several thousand years of existence. This information store is continuing to grow at a steadily increasing rate, especially becoming noticeable in the mid-1990s when the rapid growth of the internet clearly demonstrated that free and anonymous access to information and instant written communication were highly valued by most individuals. The influence of computer networks and other types of telecommunication networks resulted in network convergence. It is a process that started long before the internet. Digital voice transmission in telephone networks was one of the first signs of that convergence. More recent indications of convergence are the active development of the services of computer networks that previously were the prerogatives of telephone, radio, and TV networks such as voice over IP, radio broadcast, and TV services. The process of convergence is continuing, though without offering clear signs of its future. However, knowing the evolution of computer networks makes it easier to understand the main problems that developers of computer networks will face. So we see here the process of convergence. So what is convergence? Convergence is what we call the interaction of one object to another. So in this case, the convergence between telecommunications and computing, telecommunications in the form of radio, telephone, and TV networks. So as you can see now, almost everything is found on the internet. We could communicate with anyone, we could hear or listen to music, and we could see shows, videos, and the likes. So in this diagram, we notice the convergence between telecommunications and computing. Possibly the oldest example of network covering large territories and serving multiple clients is the water supply system of ancient Rome. So during the time of ancient Rome, in order for them to have accessible water throughout the town or the city, they build large canals wherein the those canals runs from kilometers to hundreds of kilometers from the mountain to the town. So that in itself is a network. But no matter how remote and distinct by their nature, different networks can seem, they all have something in common. For example, it is possible to draw a clear analogy between the components of electric networks and those of any large-scale computer network. That is, the information resources found in computer networks correspond to power stations. Communication links of computer networks are analogous to high-voltage transmission lines, and access networks are similar to transforming stations. Finally, both in computer networks and electric networks, one can find client terminals or end-user workstations in computer networks and household electric appliances in electric networks. So as you can see, almost all networks are the same, no matter how far in between they seem to be. Like for example, computer and electric networks, they have terminals, client terminals. They have links or communication links such as power lines, routers, and then in the form of electric networks, it is through transformers or transforming stations. On one hand, as seen on the figure above, computer networks represent a particular case of distributed computing systems in which a group of computers operate in a coordinated manner to perform a set of interrelated tasks by exchanging data in an automated mode. Computer networks can also be considered a means for transforming information over long distances. To do so, computer networks implement various methods of data encoding and multiplexing that are widely adopted in telecommunication systems. Batch processing system. First, consider the origins of computer networks. The computers of 1950s, which are large, bulky, and expensive, were intended for a small number of privileged users. Quite often, these monstrous constructions occupied entire buildings. Such computers were not able to serve users interactively. Instead, they batched jobs and delivered the results later. So, as you can see here, manually, to the user, they place jobs to the input device, which then goes into or stored into this array and pass on to the mainframe. Batch processing systems were usually based on mainframes and were powerful and reliable universal computers. Users would prepare punch cards containing data and program code and would then transfer these cards to the computing center. Operators would enter these cards into the computer and users would receive the results a day later in the form of a printout. Thus, a single punch card containing an error would mean a delay of at least 24 hours. Obviously, from the end user's point of view, an interactive mode of operating that allows them to manage the processing of their data on the fly from the terminal is more convenient. The interests of end users were substantially neglected at the earliest stages of the evolution of computing systems. The efficiency of the operation of the most expensive component of a computer, which is the processor, was regarded as of paramount importance, even at the expense of the user productivity. So during those times, batch processing system, imagine how long it was for the result to be obtained. Any single error would render the entire day as a failure because a single error would delay the result processed by the mainframe computer. Multi-terminal systems, prototype of the computer network. So in multi-terminal systems, we have here different floors wherein the terminals are interconnected to the mainframe. As processors become cheaper in the early 1960s, new methods of organizing computer processing appeared. These methods provided the possibility of taking end-user convenience into account. Multi-terminal systems evolved, such time-sharing systems. The computer was at the disposal of several users. They had their own terminals from which they could communicate with the computer. The response time of the computing system was short enough to mask that the computer served multiple users in parallel. Okay? So the computer resources was shared among several users, but because of the short processing time, it is not that obvious to the multiple users connecting to the mainframe. Terminals moved out of computing centers and onto desktops of our entire organizations. Although processing power remained fully centralized, some functions, such as user data input and output, become distributed. Such centralized multi-terminal systems look similar to a LAN or local area network. End users perceive networking at the terminal practically the same way that most people now view working at a PC connected to a network. The user can access shared files and peripheral devices and maintain the illusion of using the computer in an exclusive mode. So the user could start any required program at any moment and receive the result almost immediately. Some users were even convinced that all calculations were made somewhere inside the computer display. Multi-terminal systems working in time-sharing mode became the first step toward the development of LAN. However, the evolution still had a long way to go before LAN appeared, because multi-terminal systems retain the essential features of centralized data processing despite superficial resemblance to distributed systems. Organizations didn't feel a pressing need for LANs. Within a single building, there was nothing to connect to using a network. Most companies could not afford the luxury of purchasing more than one computer. During this period, the so-called Rush Law, named after Herbert Rush, was universally true. It represented, it represented empirically the technological level at that time. According to this law, the cost of computer system increases as square root of the computational power of the system. Hence, it was more profitable to purchase one powerful computer rather than two less powerful ones because their total computational power proved to be significantly lower than that of the expensive machine. First, computer networks. The first wide area networks are one. By contrast, the need for connecting computers located a long distance from one another was already imminent. It started with the solution of a simpler task, providing access to a computer from remote terminals located hundreds or sometimes thousands of miles apart. Modems were used to connect terminals computers to telephone lines. Such networks allowed multiple users or multiple remote users to access the shared resource of several powerful supercomputers. By the time distributed systems appeared, not only were the connections between terminals and computers, connections between computers were also implemented. Computers became able to exchange data in automatic mode, which is essentially the basic mechanism of any computer network. Developers of the first networks implemented services for file exchange, database synchronization, email, and other network services that have become commonplace. Chronologically, ones were the first to appear. Ones joined geographically distributed computers, even those located in several cities or countries. It was in the course of the development of ones that many ideas fundamental to modern computer networks were introduced and developed, such as multi-layer architecture of communication protocol, packet switching technology, and packet routing in heterogeneous network. Although ones inherited many features from older and more widespread long-haul networks, such as telephone networks, the most innovative feature was to depart from the circuit switching principle, which had been successfully used in telephone networks for decades. The circuit switching principle, if you have watched old movies wherein users or the actors were trying to call one person to another in a different location, operators were needed in order for them to transfer lines from one line to another. So that is circuit switching. So you need to call up the operator and then request that you be connected to another network. A circuit with a constant speed allocated for the entire session could not be used efficiently by the bursty traffic of computer data. Bursty means periods of intense data exchange needed to alternate with long pauses. Experiments in mathematical modeling have shown that networks based on the packet switching principle can more efficiently transmit bursty traffic. According to principle of packet switching, data are divided into small fragments known as packets. The target host address is embedded into a packet header, allowing each packet to travel over the network on its own. Since the construction of high-quality communications line connecting distant location is very expensive. The first one often used available communication links, initially intended for quite different purposes. Example, once for a long time were constructed on the basis of telephone lines. Because the transmission rate of discrete computer data using links is rather low, hundreds of kilobytes per second or kbps, the set of services provided by such networks were limited to file transfer, mainly in background mode and to email. In addition to the low transmission rate, such channels had another drawback. They introduced significant distortions into the transmitted signal. Therefore, network protocols at once using low-quality communication lines were characterized by complicated procedure for data control and restoration. A typical example of such network is the X25 network developed in the early 70s when low-rate analog channels leased from telephone companies were prevalent for connecting the computers and switches of ones. In 1969, the U.S. Department of Defense initiated research into joining the computers of defense and research centers into a network. This network, which became known as ARPANET, served as a starting point for the construction of the first and most widely known one, known as the Internet. ARPANET joined computers of different types running various OS with different add-on modules by implementing communication protocols common for all computers participating in the network. Such operating networks can be considered the first true network operating system. True network operating systems, in contrast to multi-terminal ones, allow the system not only to distribute users but also to organize data storage. They allowed for processing to be distributed among several computers by electric links. Any network operating system is capable of performing all functions of a local operating system and of providing additional functionality, allowing the system to communicate with other operating systems via the network. Software modules implementing network functions were introduced into operating systems gradually with advances in network technologies and computer hardware. As tasks require network processing period. The progress of one depended mainly on the progress of telephone networks. This resulted in the arrival of high-speed digital channels that connected automatic telephone exchange stations and allowed simultaneous transmission of tens or even hundreds of conversations. Special technology was developed for the construction of transmission networks or backbones. Such networks do not serve end user, rather they represent the foundation upon which high-speed point-to-point digital channels are based. These channels connect the equipment of another network that serves end users. Initially, transmission networks represented exclusively internal technology used only by telephone companies. Gradually, however, these companies started to lease parts of their digital channels connected into transmission networks to companies that use them for creating their own telephone networks and ones. Nowadays, transmission networks have reached data transmission speed to hundreds or gigabytes per second, and in some cases, to several terabytes per second. These networks cover the territories of all main industrial states. Both variety and quality services have helped ones catch up with lands, which had been the leaders despite the relatively late arrival. This is the first local area network. So notice we have multiple departments under enterprise. There are independent operation of several mini computers within the same enterprise. In the early 1970s, an event took place that had the greatest influence on the evolution of computer networks. As a result, large-scale integrated circuits or LSI devices appeared. They were characterized by relatively low cost and advanced functional capabilities, leading to the development of mini computers, becoming the real competitors for mainframes. Gauss laws is to represent reality since a dozen mini computers having the same cost of one mainframe were capable of accomplishing some tasks, especially ones that could be executed in parallel much faster. From that moment, even small companies could enjoy the possibility of having their own computers. Mini computers can carry out tasks such as controlling technical equipment or managing stocks. This was the origin of distributed computing concept, with computing resources becoming distributed over the entire enterprise. All computers with the same organization, however, continued to operate independently. Types of links in the first line. So we have here mini computer to mini computer. So we have an interface unit that they can be interconnected. We have a set of personal computers. We also have a computer to interface unit going to personal computers. And personal computers querying the mini computer. Types of links, with time, the needs of computers users evolve. And users are no longer satisfied with isolated work on the standalone computer. For instance, they need to exchange computer data, often automatically with users in other branches and offices. To satisfy these requirements, LANs appeared, or local area networks appeared. Various proprietary interface using proprietary methods for data representation and communication links, cables, etc. could connect only specific types and models of computer, namely the ones for which they were designed. Some examples are the interface for connecting PDP-2 mini computers to IBM S60 mainframes or HP mini computers to LS2 microcomputers. The adoption of PCs was a powerful incentive for the development of these technologies because they become ideal elements for building networks. On the other hand, they were powerful enough to support networking software. On the other hand, they obviously need to connect their processing powers to solve complex tasks and share expensive peripheral devices in these arrays. Because of this, PCs became prevalent in LANs, not only playing the roles of client, but also performing data storage and processing center functions, becoming several network servers. As PCs became more popular, they forced mini computers and mainframes out of this role. Both standard LAN technologies were based on the same switching principle that turned out to be so successful when transmitting packet demand, which is the packet switching principle. The process of building LAN then turned from handcrafting to a standard procedure using standard networking technologies. To build a network, it was enough to purchase a standard cable and network adapters according to the required specification. Ethernet, for example. Connect adapters to the cable using standard connectors installed on the computer, one of the network OS popular at the time. Example was Novell NetWare. Then developers introduced many innovations affecting the organizations and users' work, such as accessing shared network resources, becoming significantly simpler. In contrast to one, people using LANs were released from the necessity of memorizing complicated identifiers of shared resources. For this purpose, the system would provide list of available resources in a user-friendly format. The other advantage of working in LANs was that after establishing connection to the remote resource, people could access the resource using the same commands that were used when working with local resources. The arrival of large numbers of end users freed from studying specialized and rather complicated networking commands became the consequence, as well as the driving force of such progress. So the question arises that why all of these conveniences become available to end users only with the arrival of LAN. Mainly because LANs use high quality cable lines, even first generation network adapters ensure a data transfer rate of up to 10 MB. LANs are characterized by limited expansion. The cost of such lines was manageable. For this reason, economizing on the bandwidth, an important factor with the early one technologies, was not primary concern in the development of land protocols. Under this condition, periodic server broadcast of resources and services became the main mechanism organizing transparent access to land resources. In the late 90s, the internet became the undisputed leader in land technologies because classic internet and Mbps technology, this family included fast internet or 100 Mbps and gigabit internet, which is 1000 Mbps. Simple algorithms ensure the low cost of Ethernet equipment. The range of data transmission speeds enabled network architects to use a rational approach when building LANs, choosing specific Ethernet technology that best satisfy the requirements of the enterprise. All Ethernet technologies closely resemble one another by operating principles, simplifying maintenance and integration of such networks. So we have here the chronological history of the most significant events in computer networks. So from the late 60s to 1991. Convergence of LAN and WAN. By the late 80s, the following differences between LANs and WANs were evident. Link and quality communication. LANs are distinguished from WAN by small distances between network nodes. Principally, this factor enabled network developers to use communication lines of higher quality than those for WAN. Complexity of data transmission because of the low reliability of physical communication channels once required more sophisticated methods of data transmission and more complex equipment than LAN data exchange. In LAN, the peaks 10, 16, and 100 MBs were significantly higher than those ones from 4 to 4 KB to 2 MB. Variety of services. High speed of data exchange allowed network developers to implement a range of services in LAN, such as sharing printing devices, modems and packs, access to centralized database, and email. Gradually, the difference between LANs and WANs began to diminish. Network developers started to join isolated LANs using WANs as connected media. Close integration between LANs and WANs resulted in significant interpenetration of appropriate technologies. The dominance of IT or Internet Protocol has contributed to the convergence of LANs and WANs. Nowadays, it is used over LAN or WAN technology, including Ethernet, Token Link, ATM, and Frame Relay, to create a unified network on the basis of various subnets. From the 90s, WANs operating on the basis of fast digital channels have significantly widened the range of services earlier developed in LAN. The World Wide Web or Internet, a hypertext information service that became the main information service on the Internet, is the most impressive example. Interactive capabilities of this service long ago exceeded the capabilities of similar services provided by LAN. The process of porting Internet technologies into LAN became so widespread that quite soon the specialized term intranet appeared. Other evidence of the LAN WAN convergence is the arrival of the Metropolitan Area Networks or MAN, which is an intermediate position between LAN and WAN. They are intended for serving large cities. They are characterized by backbone speeds of 155 Mbps or higher, providing an efficient way of interconnecting LANs as well as connecting LANs to WANs. They were initially developed only for data transmission. Nowadays, the range of their services has been widened. Convergence of computer and telecommunication network. The trend toward convergence of computer and telecommunication networks of different types grows stronger every year. Attempts are made to create universal, so-called multi-service networks capable of providing services for computer and communication networks. Telecommunication networks, including telephone, radio, and TV networks. The main feature that makes them similar to computer networks is that information is the main resource provided to clients. However, these networks, as a rule, provide information in a different form. Example, computer networks were initially intended for transferring alphanumeric information, simply known as data. As a result, computer networks can also be called as data networks. Telephone and radio networks were developed for transmitting voice information only. TV networks are capable of transmitting both voice and video. Despite this, the convergence of computer and telecommunication network is in progress. First, convergence of service types provided to the clients is to be noticed. The first attempt to create a multi-service network capable of providing various services including telephony and data transmission, resulted in the development of ISDN or Integrated Services Digital Network technology. However, ISDN now provides mainly telephone services. For now, the internet is the main candidate for the role of global multi-service network of the new generation. Especially attractive are new types of integrated services containing several types of traditional services such as unified messaging, combining email, telephony, fax service, and paging. In practice, IP telephony, which is currently used directly or indirectly by millions of all users all over the world, has proved to be the most successful. However, the internet has a long evolutionary way to go before it becomes a true new generation network. Supplementary services provided by telephone networks such as call transfer, conferencing, and telephony can be ensured by using the intelligent network, which represents a computer network with servers in which the service logic is programmed. The use of packet switching for the simultaneous transmission of heterogeneous traffic, which includes voice, video, and text, has increased the importance of developing new methods to ensure quality of service. Methods to ensure quality of service are intended to minimize the delay level for real-time traffic, such as voice traffic, and to ensure an average information rate and dynamic data volume. However, it should not be assumed that circuit switching methods have become obsolete and therefore have no future. At this new stage of technological evolution, they also find their application but in newer technologies. Computer networks, in turn, have borrowed quite a lot from telephone and TV networks in particular. Although the internet and corporate networks lack the high reliability typical for telephone networks, computer networks have started to add to their armory the reliability tools normally used in telephone networks. It is becoming increasingly obvious that multi-service networks of the new generation cannot be created as a result of the victory of a single technology or approach. It can be created only as a result of convergence process, which takes all the best features and characteristics from each technology and joining or combining them into a new technology that provides the required quality for supporting the existing services and for creating new ones. To designate this approach, info communication networks was introduced that explicitly specifies two components of contemporary networks, which is computer-based and telecommunications. Since this new term has not gained sufficient popularity yet, we will use the standard and generally accepted telecommunications network in its extended meaning, including computer networks. So that is our lecture about the evolution of computer networks, as well as further reading and information regarding LANs, WANs, MANs, which we have covered in Unit 2. Thank you and have a good day.